And we're back
Hello,
again.
and we're back.
For the last speech of today. It's Mr. Johannes Traxler. This is almost correct. Now it's correct. Mr. Johannes Traxler, the CEO and founder of EYYES. So let me add Johannes to the stream. Hello, Johannes.
Hello.
Yeah, actually.
Hello, good afternoon.
Good afternoon.
EYYES is a rather new name. You might not be familiar with it because the original name of the company was AVI Systems, and it was coincidentally also one of the first companies I met in Austria which do AI hardware, I would say chip design, FPGAs, and so on. I think it was 3 years ago on an AI Austria meetup in Vienna, where for the first time you presented your patent together with your research partner and so on. I remember it's like the intelligent rearview mirror.
Right. And today I'm going to present what we did till this presentation three years ago, and what our technology platform is able to do now, and what we are offering for users and customers who want to build embedded on the edge applications with deep learning inside.
Excellent. So I already mentioned to you before, due to the technical problems with the cloud service, no videos today, it's just slides. So as in the previous talks, we hand over the stage to you and then come back for the Q&A session. And as always, the invitation to the audience, if you have something to ask to Johannes, shoot the questions on LinkedIn.
So let me pull up your slide. And yes, it works. With this out of the way, I'd say the stage is yours. We see each other for the Q&A session.
Thank you very much. Yeah, as I already mentioned, I'm proud to present our new technology platform. And at the beginning, I want to ask you who needs a GPU if he can have an LPU. So for sure you are asking now yourself, what is an LPU? And that's why I'm stepping into the next slide to show you what the LPU means. At the beginning, let me say a few words about EYYES. As Clemens Wasner already mentioned, we changed our name. We have been AVI Systems till 2020, and we switched to the name EYYES because it more shows what we are doing. Our claim is we make machines see, so we are providing safe and artificial-based solutions for different kind of applications, different markets, and we are not ending on the let's say ECU end of the communication. We are also building our own sensor systems and complete solutions if it makes sense. Where are we located? Our headquarters is in Krems in Austria, near Vienna, 60 kilometers in the west of Vienna. And we have two sites in Germany, one in Freidal near Dresden. In the former presentation, the name Silicon Saxony was already taken or explained several times. So we are with our site also in this area, and that's why there is our development center of embedded systems and electronics. And we have one site in Aachen where the AI specialists and machine learning experts are located. And here in Austria, we have, let's say, the core development and production plant. So let me start with the explanation of our deep learning technology and the evolution. At the beginning, of course, I'm sure everybody knows it, the amount of operations needed to calculate CNN, for example, on image data or other kind of data is very high, and that's why very efficient ways to calculate this amount of operations in a short time is needed, and this was the situation or the issue we were facing in 2016 when we started to investigate into that problem. We started with some research projects with different kind of partners. One of the beginning project, this was the project that we were presenting in Vienna 3 years ago, was our artificial intelligence review system research project. It was funded by the Austrian FFG, and we had a project partner, the Software Competence Center Hagenberg there, who were supporting us, especially regarding the object tracking and time series algorithm that we were investigating in this project. Then we had the project in Germany running. It was called RailEyes 3.0 together with the Technical University in Dresden, where the, let's say, hardware platform was designed. Here you can see a picture of the first version of the board we developed together with them. And it was, let's say, a very early start, and we were facing the problem, it's really difficult to get a deep learning application running on the edge. And to summarize the issues we were facing, I want to tell you that at the first point we had the problem that we had to find a solution to minimize the dimension or the size of the neural network. Of course, it should be optimized in that way that the needed operations are as less as possible. Then we had to improve the training algorithm itself. We were facing the problem that in different applications, for example, in the rail market or also in automotive market, it was difficult to get a ground truth. If you are expecting millions of pictures and you have to annotate them manually, you can imagine that this is a very big effort, and therefore we were looking for solutions. How can we automate this? How we optimize this training process? And then, of course, we are coming from the functional safety area, so we are in our projects always facing, let's say, safety issues. The system have to guarantee some core functions, some safety functions, and therefore we were looking for solutions to build explainability in our neural network approaches. And at the end, of course, we had to find a solution and hardware platform that enables us to bring this neural network intelligence into the vehicle, where we always have harsh environment with less energy available and different requirements regarding interfaces and everything else. So let me step into the challenge one. This was the challenge we were facing regarding quantization. Of course, we took the decision in 2016 that we do not think that it will be possible to equip systems in our project with GPUs. We were looking for a solution that brings us in the position to use parallel processing platforms with less power consumption. And therefore, we were looking for a solution to quantize the neural networks down to 4-bit, if possible, without losing a lot of information and reaching the same mean square error as the original neural network. And therefore we were developing some very innovative approaches that we put into a patent in 2019. And of course, at the same time, we were facing the issue that if we find an inference platform, we will have to build an adaptation stage and adaptation tool chain that enables us to bring a pre-trained neural network into the inference platform. And both things together were one big development project in 2018, where we also started to bring our technology into real-world systems and vehicles. And the outcome of this development project was our tool chain, group of tools that we can provide to our customers, starting with the training itself or using pre-trained neural networks and transfer learn techniques to minimize the outcome of this step using pruning and cutoff technologies, optimize the outcome of this network, of this step, simulated with the focus on the platform that is decided to deploy the neural network on the edge, and then an export tool to bring the result into our platform. And here there are some comparisons between our technology, and in this case we took TensorFlow Lite as an additional or comparable optimization library. And here you can see that the quantization loss is much lower using our technology compared with TensorFlow Lite, using these special, let's say, techniques that we were developing in our tools. So we passed this first challenge, and we could offer a tool chain that is able to bring our neural networks or other neural networks into a very minimized dimensional size. The second step was the decreasing of the calculation or operations itself. Of course, it's a little bit mixed with the challenge one. There we were using, in addition or in front of the quantization step, pruning and cutting techniques. And here you can see the decreasing of parameters, for example, or other operations that are needed via the different layers. And we could show that we can minimize the neural network, keeping the same mean average precision values as it had in the original version. So we also passed this challenge too. Here you can see a comparison between a tiny YOLO v3 and our solutions, and also the reduction using specific batch norm and optimization approaches. Yeah, of course, the important thing is to keep the performance as high as possible. And as I mentioned at the beginning, to make the system reliable, and therefore we were researching on explainability approaches, different kind of algorithm that enables us to get, in addition to the common confidence value, additional results that that bring us in the position to decide if the actual outcome of the neural network is reliable. And therefore we were using, we called it real-time explainability approaches that brings us or gives us the results that we can decide if, for example, an object, as you can see here on the right lower part of the slide, if the center of the object, for example, is a possible center, if this could be a person or not, or if, for example, here in the upper part of the picture, there were some parts of the picture that also caused a higher response of for the neural network, and we can adjust or decide with a priori knowledge, for example, or other logical rules that this example or this result cannot be realistic or cannot be a true object. And using these techniques, we can increase the reliability of the result of the neural network. And at the moment, we are in a research project to bring this into our hardware platform and use this in real time in an realistic or real world use case. So, and the fourth challenge was to implement or to realize a parallel processing unit that enables us to realize an on-the-edge application with very low power consumption in an on-vehicle use case. And when we started in 2016, there was no real platform existing that we could use and take in our project. So we started to develop our own processing unit, and the outcome of this research and development project was the today called layer processing unit. It's compared to an GPU, which is using vector operations, or a TPU, which is optimized for tensor operation. A specific processing unit that is optimized for processing a complete layer in one step. So it's not only different tensor operations in one step, but also addition or activation function comparisons, and this all can be done in a parallel way. So if you are putting data into this unit and you give it the correct parameters and you add a clock signal on the unit input, then you would directly get the result of the layout. And this means that it's a very optimized and high efficient processing unit that enables us or enabled us to build the first products out of it that we are already using now in the market. Yeah, this is just a very rough picture how it works. So you add the input data or you connect the input data into the first layer, add or step over it with one clock, and the results are then directly connected to the next layer. And again, you put it or you give one clock to the LPU, and then you get the result for the next layer. And so you step through the whole deep neural network until you get the result at the end. And the reason why it is so high efficient, as we already have heard in the former presentations, the big limitation is always the bandwidth through the to the storage or to the memory. And we were implementing or realizing a solution that is decreasing the needed bandwidth through the memory very much, and because we keep the data inside the LPU, and this caused this high efficient processing. Yeah, this is how it looks in the technical way. So here you can see on the convolution part, the batch norm layer, the activation sublayer, and optional pooling or other sublayers stepped through with one clock. And this means that we are reaching several thousand operations in one clock. And if you imagine that we can provide at the moment on, let's say, 28 nanometer FPGA around 135 megahertz clock rate, then you can realize with this system already real-time applications with only 2 watt power consumption. This is how it looks like. At the moment, it's an IP core that you can integrate into an FPGA. And of course, we are looking for partners or customers who will enable us to bring the LPU into a real-world ASIC, so that we can optimize the bandwidth through the memory and additional integration steps that we already have in mind, but we cannot do today on the FPGA in a specific chip that will be able to increase the efficiency and also decrease the needed power consumption. This is how the IP core is looking like today. So at the moment, we are able to provide different kind of kernel width and height, different kind of strides, padding, and so on. The important thing is that the LPU is a generalized processing unit, which means that it can be used for, let's say, in principle, any kind of network model. Of course, there are restrictions according the realized or implemented activation functions and kernel sizes and etc. But in principle, it's generic, and you can change the model during runtime. So you can also use it to run different kind of models in not the real same time, but in different clocks, and switch between these neural network models. So it's a very flexible platform, and in that a very future-safe technology. So if you are using an LPU in your system, you can always update or upgrade the system. And so we also managed the challenge 4 and reached a very high efficient platform. So at the end, of course, some few words about the safety topic. We, as I mentioned, are always working in a safety near area where we need some reliable results out of our systems. And therefore we are using, or we integrated some first explainability approaches in a runtime environment. Of course, this is still a research area where we are at the moment working together with our partners to find final solutions to, let's say, integrate an additional percentage or confidence value into the result and get it running in a fully integrated application. And we think this will be the real big next step to get, for example, autonomous vehicle or robotics more reliable and realize more complex applications. So to summarize, our layer processing unit is a very powerful and efficient mobile and embedded parallel processing unit. It's extremely high processing performance combined with low costs, which is also, of course, very important at the end. It's open for any kind of neural networks model, and it is able to process in real time with a very low latency caused by parallel processing for any kind of real-time application or also low-power application that might come up for deep learning use cases. And to offer our customers a solution that they can integrate into their systems or into their applications, we were facing the issue that we also have to provide some kind of platform, some kind of PCB that is easy to integrate and that can be used in many different applications. And therefore, we were developing our so-called real-time interface in the version 3 now. The first 2 versions are already used from us in our own products. For example, the real-time interface 2 is used in our turn assistant system, the worldwide first turn assistant, truck turn assistant system based on deep learning technology. And the real-time interface 3 is now a more flexible platform with pre-installed Linux operating system and with different kind of interfaces that make the platform very, we think, useful for different kind of applications. Here you can see a rough overview of the components and interfaces that the real-time interface is providing. We have on the one hand 2 FPD Link 3 serial interfaces where we can connect any kind of FPD link camera or sensors, and the interfaces are also used to integrate, for example, our own Full HD sensor board. Then we have an own developed image signal processing core that is able to control and steer the different FPD Link 3 devices. And we have an integrated encoding, which native provides H.264, and for special projects also MPEG-2. An ARM processor, which is on chip, and the layer processing, of course, which is a pre-installed IP core that can be controlled out of the Linux operating system. And additional interfaces like UART and Ethernet, of course, to communicate with the device, and the gigabit transceiver to be compatible with our own baseboard that can be used to build up more powerful systems or an ECU, for example, to control different kind of vehicles or robots. And of course, we are offering, in addition to the electronics, also the software stack to enable our customer to bring their own pre-trained neural network on it, or you can use our pre-installed CNN called EYYES-LPU, which is able to detect up to 21 classes of objects, of course, specialized for automotive applications or automotive near applications. Any kind of object classes and object types are detected from this neural network. And you can combine this very flexible with our different IP cores as needed in your own use case. So how does it look like? This is a picture of our RTI3. You can see here there is a Xilinx MPSoC on chip on board, and you can see the 2 FPD Link 3 interfaces here with the FAC Rosette connector. And as I already told you, there is an Ethernet interface on board. You can connect via standard Ethernet through the operating system, and there is a web server inside that will or that is enabling you to configure the system, to set, for example, IP addresses, etc., and to select the correct neural network you want to use. And everything else is, let's say, out of the box. So we have the possibility to show the features and the efficiency of our layer processing unit now on a hardware platform. Yeah, here the summarization of the different features again. Here you can see two examples of sensors or cameras we are offering two different kind of housings that you can use in your project. They are already ruggedized, so they are have an increased protection level of 67 and heating inside and so on. But therefore, you can go onto our homepage, www.eyes.com, and there you can find more details about the different components. So to summarize the next steps, the RTI3 I showed you in the slides before will be available in autumn 2021. So at the moment we are in the prototype phase, and as a product it will be available in autumn. Pre-built use cases will be pre-installed, so it's ready to use as an let's say custom off-the-shelf product. Extended parameters and support mechanisms for different models will be provided. This is where we are in different research projects still working on, and it will be available in different applications with different cable sets and configurations. Yeah, and you can increase the performance factor of up to 2 using event-driven approach, which will be the next release from our LPU. So we are working on additional improvements of the processing using, let's say, spiking neural networks approaches, and this will be also available till end of the year. And we always have the philosophy that we will provide, or we will offer upgrades then for already existing LPU users. So it's a future safe platform. And here there is the outlook. As I already mentioned, we are starting with the RTI3 in autumn, and we are working on additional neuromorphic approaches, and are planning to offer it as an additional product step in 2023. So, and now I would like to share the video with you. I hope this will work, to give you an idea what our existing EYES-Net is able to do. It seems to run. Okay, here we have a video from a test drive from the inner part of Vienna. And you can see on the different frames of the object, there is on the upper left side, on the one hand, the distance written. So we are using 2D, 3D matching algorithms for that. And the confidence level of the object using a combination of, let's say, the standard confidence values and explainability approaches. And yeah, here you can see that the different object classes that we are providing at the moment. So, and to finalize the presentation, these are the markets where we are already inside, where we are offering existing products and solutions. So we are not only talking about this technique, we are really already in the market. In railway business, we are providing front collision assistant, blind spot information systems already. SIL 1 certified rear view systems. And in the automotive market, our own product, our turn assistance system for trucks. And we are working on blind spot information system, and we are part of projects for autonomous driving and prototype vehicles, and are offering intelligent rear view mirror and 330 degrees surround detection systems. All these solutions are based on our electronic platforms or electronic components, where the RTI3 will be a very important next step. In the security market, applications like intrusion detection, people counting, bicycle driver detection, zone surveillance. In the traffic market, vehicle identification system, traffic analysis system, red light enforcement, till tunnel sensor fusion and parking systems. And in the manufacturing area, very specialized discontinuity detections on transparent painted parts or on intransparent painted parts. This is an additional AI area where we are working now for 3 years already. So I hope the presentation was interesting and gave you an overview about what we are doing. And to summarize or to give you our vision at the end of the presentation, we are providing explainable embedded AI solutions for a safer world. And I think this is a very good reason to work in this area, and gives us the right drive to go in the right direction. Thank you.
Thank you so much for your presentation. It's amazing to hear where your technologies are applied, and this was very, very insightful. We have Baby Clemens here on my side. I see one question. It's also going to the technical part a little bit, and we received it about 20 minutes ago. So apart from TensorFlow Lite, did you ever try to compare to Apache TVM, which is used by most of the major chipset vendors?
Yeah. At the moment, I have to say no. Yeah, we are working on this, but at the moment I cannot provide results. But we know Apache TVM, and we are thinking that it might be comparable, but at the moment we do not know.
Yeah, he also sent for reference. Yeah. All right. Thank you very much, Remco.
Yeah. The point is, I think, of course, there will always be an improvement, especially for optimization tools, and it's very hard to always stay on the top. But our LPU itself, it's more or less an independent step of that. Of course, we are using our own tools now to build our own applications. But the real idea, or the major idea behind this, to promote the LPU as an additional platform, because we think our investigations showed us that we really have a big advantage there. And at the end, Apache TVM could also be used, because at the end it's optimizing the neural network for a specific processing technique. And why not using an LPU there as one of these platforms? So it's not a competition, it's more an additional tool that we could also provide for our customers.
Make use of. Okay, great.
Yeah, then I would actually have a question, because as both you and me mentioned, when we met 3 years ago, you were really in the first innings of going in the direction of the LPU. I think back then the name didn't even exist, or let's say the abbreviation. How difficult is it, in your opinion, for a European startup to do this type of a pivot towards deep tech, while at the same time still running customer projects? So you're basically solving two problems at the same time.
Yeah, this is always very difficult, of course, because we have to earn our own money at the end, and this is really hard. Yeah, of course, I have to say, using the public funding, this was a very important step. Otherwise, it would not be possible. But even with this money, we always are facing, of course, the issue where what we should prioritize more, and because this area is developing so dynamically, you cannot stop researching for even 1 month there. Otherwise, there is so much improvement already, and you are losing the target, or you are losing your position. This is hard for us, but I would say we managed it till now very well.
May I ask, how large is your team at the moment?
At the moment, we are a little bit above 30 people, and around 20 people are working in the R&D department. It's of course still as in classical SME, but we have now a long-term relationship with our experts, and at the end it's normally not a question of the quantity. So it's always it is very important that the people who are working in this area have enough experience.
I mean, in terms of team size, this is a remarkably high number, because in Austria, I mean, obviously in Austria, but still in startup land, you normally have much smaller teams operating. So you received quite a scale, considering in which field you're in. It's not like you have 25 people doing BD code calls all day long, if you know what I mean.
Yeah,
that's quite an accomplishment.
That's a size where you can earn your own money and still stay on the top of developments.
It's possible. Yeah, of course, we have a lot of heads always on, so we are switching every day in many different roles. And of course, what is also very let's say difficult is that, for example, in the rail market or in the automotive market, even if we are such a small company, we have to fulfill all the standards and process requirements like a company who is manufacturing millions of vehicles. So this is an additional issue we are facing here in Europe. But I would say we found a good approach to bring all together.
Excellent. Speaking of many hats to wear, maybe one final, that's not really a question, but like a statement. We always ask our participants for a call for action. You mentioned that you're looking for cooperation partners and clients. How about investors? Because on our previous event that just ended 3 weeks ago, we had a deep dive on investments, and there you had like Early Bird Ventures, Atomico, and so on. Are you also raising money at the moment?
Yes. Yeah, we are at the beginning. So we did one investment round in 2019, and this year we are planning the next step. And we are at the moment in the preparation of it. Yeah. So in autumn, we will go on the market with the new investment documents.
Interesting. Yeah.
So we are looking for some new partners there.
Great. Yeah, as far as questions are concerned, we are through. Yes, thanks a lot, Johannes. I think this was the first time we dealt with each other since then, because most of the time your colleagues are coming to our events. This time it was you again.
Right.
Yeah, it was a pleasure for me, and I enjoyed. I was listening the presentations till midday, so it was very interesting. Also, the former presentations. I think it's a very good event and very interesting participants. Yeah. Congratulations on that.
Thanks.
Thank you.
Thank you for being a part of it.
Thank you.
Yeah.
And with this, best wishes from here in Vienna.
Okay. Thank you very much.
Have a nice day and bye.
Goodbye. Goodbye.
All right, Clemens. This was an eventful day.
Yes. Melting computers, server outages, clouds gone rogue. It had it all, but surprisingly, it still worked. And nobody knocked at the door and throwing tomatoes in the office. So that is good.
That also didn't happen, yeah. Well, this is live, as I always say. But we also have some few more announcements for those who are still listening and watching. Well, to stay in the loop and to be informed on what the future applied AI conferences we are preparing, and also for the calls to action from our speakers and participants, follow us on LinkedIn and on YouTube, where we continuously post new content. Also, thank you. Yeah.
Thank you.
We appreciate it. Thank you very much. AI in Semiconductors was presented by AI Austria, Silicon Alps, and by Advantage Austria. And we thank our partners and friends at Silicon Alps, at Silicon Saxony, of course at Infineon, and at Springer Professional. Clemens, you want to lose 1 or 2 words on your upcoming events on the AI Austria side?
Yeah, 2 or 3 is right. As far as the Applied AI conference is concerned, we are now going into the summer break, so to speak. So the next event will take place on AI in the gaming industry in fall. So let's say September, October, November. It's not totally fixed, but lots of different angles how you can tackle or how you can apply AI in the gaming industry. Before that is a rather smaller event that is taking place in Tyrol each year. It is organized together by AI Austria and the IACD Hermann Hauser, which is actually quite a good match to announce this at the semiconductor event. Hermann Hauser is one of the co-founders of ARM. And each year, once he's holding an event called State of AI. So this year, we will also have him on the stage. The event will be live streamed, and stay tuned for online announcements. And as far as the other 3 events are concerned, they are, let's say, from our organization partner of today, Silicon Alps. For updates on this type of events, you head over either to the Silicon Alps homepage or on their LinkedIn channel, which also is very frequently updated with content.
Right.
And now, Matthias, I expect 500 events from the Economic Chamber.
Well, we have too much planned, but of course, AI is a topic at all the big trade shows and trade missions that we are planning. Also at the Expo Pavilion of Austria at the Expo Dubai this year. But I want to highlight 3 things that could be interesting. Our Sofia in Bulgaria office is organizing a business circle on June 22 next week. You can join in by registering online. We are in Barcelona at the IoT Solutions World Congress, which is a great upcoming event, so to say the 2nd Mobile World Congress already. And which might be interesting, an Austria showcase on AI, cybersecurity, and critical infrastructure to Jordan. You can also get in touch with my colleague Herwig Neuper at aman@advantageaustria.org. For all our friends in Jordan and in Austria, this could be interesting. Well, without further ado, Clemens, I would say we are through. It was a pleasure.
Accomplished.
And yeah, please get in touch if you have suggestions on what we could do and who we could connect, on how we could collaborate, because once again, we heard it's about connecting domain knowledge from different areas and thinking big, thinking international. So thank you for being a part of it. I want to play the video once again.
Oh, this is brave. That's very brave.
I don't know.
Before the internet explodes, if you do that, I also would like to say thank you.
Please.
Yeah, we posted the links like 50 times how you can engage with us via LinkedIn, via email, and so on. And yeah, I would also like to rephrase what Matthias said. If you have ideas on different formats or different topics we could cover, like semiconductors, like logistics, which we had, or the upcoming gaming event, just contact us. As you can see, we are very flexible when it comes to forming partnerships, like now with Silicon Alps and Silicon Saxony, and form around the, let's say, core community and international event out of it. And best of all, it's free, of course, because we are non-profit. So yeah, happy to receive your ideas in the future. And now we try the video again. So thank you very much and have a nice summer.
Bye-bye.